What actually makes a fluid look like a fluid? Is it the way it moves, the way it sticks to itself, or just the way it splashes when it hits something? I wanted to figure that out by writing my own fluid simulation, using something called Smoothed Particle Hydrodynamics, or SPH. SPH is a method for simulating fluids by treating them as a bunch of particles. Each one carries properties like mass, velocity, density, and interacts with its neighbors using smoothing kernels, basically functions that tell particles how much they influence each other depending on distance. To a single SPH particle, the world is just other particles nearby. It doesn't care about anything too far, just what's inside its smoothing radius. Once a particle knows what's around it, it needs to decide how to move. That's where the momentum equation comes in. It calculates the total force acting on the particle, mostly from the pressure and gravity, based on how close its neighbors are and where they are. But where does pressure come from? You get pressure from density, and to figure out density, a particle just checks how many neighbors are nearby and how close they are. Each neighbor contributes to the density, and the closer it is, the more it contributes. Once it knows the pressure, it compares them. If a neighbor has higher pressure, it gets pushed away. If it has lower pressure, it gets pulled towards. The strength of that push or pull fades based on the derivative of the smoothing kernel. Now we have fast-moving particles right next to slow particles. This sharp difference in speed would look unnatural in a real fluid, so we fix that by using viscosity. Viscosity simulates the internal stickiness of a fluid, how it resists parts sliding past each other. In SPH, that means we want nearby particles to gently influence each other's motions, so the fluid flows smoothly instead of breaking apart. Each particle looks at its neighbors and compares velocities. If a neighbor is moving in a different direction and they're getting closer, we apply a small force to reduce that difference. This force depends on two things: how far apart the particles are and how fast they're moving towards each other. The effect is that fast particles gently drag along slow ones, and slow ones resist fast ones pulling away. The result is smoother, more realistic movement across the fluid. But things were still breaking in strange, annoying ways. The issue? The kernel function. It turned out to be extremely sensitive. Small changes had big effects. Too much force and the whole thing blew apart. Too little and it kinda just collapsed. Sometimes the particles would fly off for no reason, other times they'd clump up and get stuck. It was a mess. And honestly, it took me way too long to realize the kernel function was the problem. I kept adjusting constants, running the sim, tweaking again over and over again. Even minor changes could completely alter the behavior. I thought the hard part would be making the particles move, but in SPH, it's really about how they interact. If the details aren't just right, everything falls apart. Don't give up while you get it just right. The results make all the struggles worthwhile. And when that happens, it feels pretty freaking amazing.